Good evening, everyone. So, welcome to the last discussion on biomass conversion and biorefinery. Today, unfortunately, no one joined till now, and I can understand that after 2 days you have exam, so you will be in the preparation of these courses as well as you will be busy in other exams also. But it's fine. In the today's uh, lectures or today's discussion, we'll go through the last week, that is week 12, integrated biorefinery questions on assignments, as this is the last lecture, that is my duty to summarize all the week content of the all weeks that will be helpful for you in your exam. So what I thought, that before that I thought I will merge all these important things from all the chapters and make it another presentation. But I think that if I will do that, then there many things will be missed out. So what we'll do, I will quickly scroll down all my 10 weeks, I think 11 weeks discussion. Quickly I will scroll down in our PDF file of all the presentations, and will so in that way you everything will be come in your in front of your eyes, so maybe you can remember something when if it is needed, and I may be obliged if something will be helpful for you get in that discussion, or anytime you can go and go through the lectures, video lectures, notes, as well as doubt solving session, PDF files, and so many things are available as a resources in the NPTEL on the NPTEL website, so you can go through it. And now I wanted to share my screen. Okay, okay, I guess my screen is visible. I will start today's lecture. I think no one will come, or if someone will come, we'll allow him to join the meeting. So the in the today's lecture, as I mentioned, we'll go through the week 12 assignment problems, that is the integrated biorefinery. At the same time, I will go to the overview of all week's content. And okay, so he's a our Professor Kostuba Mohanty. Is a facilitator of this course on NPTEL. And I again, last time I wanted to give my introduction. It is something weird that I am giving my introduction every time in every lectures, but maybe it will be helpful for someone who is needed for some contact. So my name is Bhavik, and I am from IIT Madras. This is my mail ID, ch19d75 752 @smail.itm.ac.in, and this is my mobile number, which is also my WhatsApp number. And this is WhatsApp only is working currently, as I am in Australia right now. So you can see that I already wore a sweater here, as that is a summer in the India, but it is currently winter in Australia. And this is my number. You can take it for and use it for the WhatsApp if you have any doubts and regarding this course. And if I am happy to help you if I can able to help you. Okay. Now, week 12 content is all about the integrated biorefinery. So, as the explanation started, which is a name refinery comes from the crude oil refinery, which is a conventional crude oil, fossil oils are there. We are going for the heating, and after that, we'll pour it into the fractional distillation column. So in the fractional distillation column, you will get the different fractions, like it ranges from the gas products, liquid products, and oil products, then viscous oil products, and at the end solid products out of that. And if you are going for the some chemical reaction after that, then you will get the fuels and chemicals out of it. The similar kind of concept which is replicate into the green innovation, or in the process of the biomass processing, which is known as a biomass, can be processed go for the pre-treatment digestion, and then fermentation. Out of that, depending on the feedstocks, depending on the processes, and depending on the catalysis, enzymes, and microorganisms you will use, you will get at the end biofuels and biochemicals. Okay. Okay, so in today's lecture we are going for the assignment problem of 12 week 12, as well as I will summarize all week content. Once again, I will go through week 1 to week 11 content very briefly. I will just scroll it down all the past PDFs, and that will be helpful for you in if you are going to give the exam. So we'll go quickly go through the week 12 assignment problems. So similarly, like crude oil refinery, we have the biorefinery, and you already know that biorefinery comes from the uh, algal biomass and different kind of biomass, and then you go for the pre-treatment fermentation, and depending on the requirement of product, you are going for a different kind of processes, and the eventually water the effluent it you get, it will be again go to the wastewater, and from that the cycles again go back. Now, what is the integrated biorefinery? So, as we see last time, so integrated means synthesis, design, and innovation comes in the picture when you are going for the biorefinery. These three concepts were used. How can they use the integrated biorefinery? What are the biomaterial, biochemical you are producing? For the producing, whatever amount of source and fuel you are getting, or electricity you are getting. This is also comes from the some part of biomass processing. And as you can see here, if it is pulp mill, whatever the waste is going for the bioenergy plant, you will get the energy out of it. Another waste is going for production of the biomaterials, and this electrical energy and fuels and source, everything are integrated, combined together to come as the outcome of the biorefinery. Now this is the raw definition. We don't have to go because it will take some time, and as today is the last lecture and the exam is also nearby, maybe you guys don't have that much time to go to understand each and everything. But in the simple word, a biorefinery is a facility that integrates biomass conversion processes and equipment to produce fuel, power, and chemicals from biomass. It's not only chemicals, but also fuels as well as powers from biomass. Now, United States Department of Energy and NRA further describe biomass conversion technology in the five different platforms depending on the processing. It's from sugar platform, biorefinery, thermochemical syngas, biogas platform, carbon-rich chain platform, and plant products platform. These all are different kind of biomass, and the processing of there is also quite different, and the final output of products are also different. But if you talk about the phase-wise biorefinery classification, in the phase one, the single product is coming to the picture when only one processes are there. Like if you think about biodiesel from the sunflower, many vegetable oils. In this phase two, you have one crop, multiple processes, and you will get a range of products. Here, both the where you will get only one feedstock. If you talk about the phase 3, then you have the mixed feedstock of multiple types, and that will be go into the multiple processes, and you will get the range of products. So this is how this biorefinery concept got evolved during the past times. And then there was a question asked on the similar kind of discussion that NREL discussed the five platform. Then the question asked, ethanol is produced as a main product from which of the following biorefineries? As we have seen, gas, biogas, plant product, a sugar platform. So as we also know that ethanol is alcohol, and it is definitely produced from the cellulose and hemicellulose products. So you will get from the sugar platform products ethanol or other building block chemical through fermentation of sugars. So sugars consist mainly glucose, and glucose is converted into the alcohol, as you already see. Okay, so this is all about the question, first question, and here it is mentioned. 1 minute. Sorry. So now we will go to the other concepts, like here it is a similar kind of thing, that biomass is going for the densification, extraction, and residue product, and there's in the processing, any process you are going, you require energy out of you'll get the combustion, which is from the fuel which is produced by this same process, and you will get electricity energy out of it again. It can be also recyclable. And the same CO2, whatever the CO2 you are emitting, it is again going back to the first step of the biomass production, biomass feedstock, where it combine the CO2 for enrichment of the biomass. The product they are from the biorefinery energetic products, solid energetic products, which and then it is come from the pellet form or mostly from charcoal pellets. Liquid energetic for biofuels, bioethanol, biodiesel, bioethanol, biodiesel and bioethanol, gases for biogas, syngas, and non-energetic products, which are basically building block chemicals, which are succinic acid, glycerol, or polyphenols, oxosynthesis. Uh, So today we start our discussion with the week 12 assignment problem, and then we'll switch to the all week this content. Once we'll just glance through all the content. Maybe we'll just skim only, so we'll not discuss anything, but maybe that will be helpful for you to just revisit each and every topic. We'll not go into the detail. That's it. That is a plan for today. And then some therapeutic and nucleic compounds. So integrated corn based biorefinery, as we discussed last time. So corn is the one of the major feedstock which is using for the over the last some years, and it has many different kind of products. If you talk about the integrated corn biorefinery, in the interest of time we'll not again go revisit this thing. And if you just see about the biorefinery process, then first corn will go to hammer mill, and then it will go for the cooking and liquefaction process and saccharification process and fermentation. And after this duration you will get the ethanol out of it, and whatever the solid product which where it is going for the livestock feed, and you will get the manure out of it. It is again going to anaerobic digestion. You will get the biogas, which is a methane. And after centrifuge, you will again use the liquid product out of it, and it will be again go into the cooking process. So this is how this biorefinery concept integrated with other concepts. Now the question asked on this thing is, in ICBR technology, which part of the crop was utilized for production of ethanol? So ICBR is a short form for the integrated corn based biorefinery, and DuPont started this process of ICBR, which is the integration of corn based refinery, in the association with the US Department of Energy, and it started in 2003. And uh, it is unlike the another traditional processes of biomass processing of corn, which is for getting the ethanol out of the corn grain. In ICBR technology, there is only corn kernels are used, but in ICBR technology, entire corn plant, that is not only kernels, stalks, scopes, and leaves left, as everything will be used in your further, and then you will get different kind of products out of it. So which part of crop is utilized? Stem crop as well as limb, whole crop stem. So answer is whole crop. Whole crop, it means consists each and everything. So this is the same discussion from this slide. Now integrated soybean based dry biorefinery. So as we discussed, the soybean is currently its production is increased day by day, and if you want to see the integrated biorefinery process from that, then first soybean will go for the different kind of pretreatment, which is cracker, conditioning, flaker, and expander. Then we'll go for the oil extraction, as is oil is much more important. Out of it, we're getting the oil can be used for the production of the refined oil, so which is going for the processing like degumming, neutralizing, bleaching, and deodorizing, and you will get a refined oil which is going into the food industries. And out of that, if you are separate out or desolventizing, then you will get a crude oil also out of it. And what are the mill after defeated mill desolventizing you use, then it can be used for the many kind of cattle products. And if you go for the isolation concentration part of it, then you will get the soybean molasses, which will be eventually converted into the alcohol, and you will get the whey protein out of it. And today's was soybean milk, and soybean whey protein is much more important in the form of protein. and people are consuming it a lot. So same harvest, preparation, extraction, then evaporation, degumming, neutralizing, bleaching, deodorizing, you will get the soybean oil. Other than that, you will go for this process, you will get the soy proteins and soybean molasses and other. Now, so we already discussed the last week. That's why I not want to go each and every details of this all slides, because maybe your exams also near. So I don't want to waste your time also. So the concept of integrated soybean refinery, which comes from the fact that 60% of world's oilseed production is followed by the soya. So it's come from the soybean. After that, cottonseed is coming to the picture. The soybean production in 2016 was 324 million tons, which was increased. The question asked is what percentage of increase was observed in 2016 in the global production of soybean. So there was if you talk about 2013, then 17% increment is done in the soybean production, 324 million ton, which is exactly 17% more than 2013. And 78 to 80% grain is transformed into grain. Okay, someone is okay. So in today's discussion, we will go to the assignment problem of week 12, and then all week content in the PDF format. So just you will just revisit all the concept within I guess not more than 30-40 minutes. We'll just skim through all the topics again. So that is a plan for today's discussion, and now we are solving the uh, assignment problem of the last week. So global soybean production was increased 70%. It was the answer of this question. And the integrated soybean based biorefinery, uh, as we discussed last time already, I don't want to waste your time, but if you talk about this, then SPC is going to desolventizing, carbohydrate extraction, this one day. After that, you will get into the molasses. And now, how it is a soybean based integrated biorefinery, we see in the last to last slides. But now, how many kind of products you will get? So if you're going to this process, you will go for the cow generation system. Then you will use the molasses of soybean in order to generate the electricity and steam, and that will be useful. And for that process you want water, so water is generated out of the process and you will get some waters out of it. Other than the soybean is main is oil extraction process, where you prepare the do the pretreatment and preparation of the seed, oil extractions, which will, and then solid product whatever you will get, it will go into the again back to the carbohydrates extraction stage. What are the micelles you are getting, just for the desolventizing crude oil you are getting. Now is this crude oil can be converted into the many kind of products. So after degumming, neutralizing, bleaching and deodorizing step, if you are using this crude oil, then it will go for a transesterification process, you will get the glycerol and biodiesel. In the any of the step we are going for the esterification or saponification process or transesterification process, and then you will get the glycerol and biodiesel. If you are it whatever the gum parts is there, solid part you will dry, you will convert into the proteins like lecithin. And at the end also for the concentrates and part you will go for the tocophenols, and then you will get the refined oil which is going into the food industry. Now the question asked is what are the main refining steps are involved as a assignment question. And the question the refining process steps are degumming, neutralization, bleaching and deodorization. This is the always process, this four processes always involved in the soybean based biorefinery processes. Now, so question that's which are the steps? So degumming, deacidification, clarification. Now they change the name here a little bit. So if you come, degumming is the same degumming which is a one is wanted to join. Okay. So we are going to the week 12 discussion assignment problem, and then we'll switch to the all week content. We are just skimming all the contents. Okay. So degumming is actually the hydration process. And if you go for the neutralization, which is nothing but the neutralization means it has a deacidification step. Why? Because it is in the base acids are there in the soybean. So if you remove these acids out of it, then it will convert into neutralization step. Then the bleaching, which is nothing but the clarification as it is mentioned here, and then the deodorization process. So all three are there. So answer is to all of the above. Now integrated sugarcane based biorefinery last week we visited, because sugarcane, mainly if you go for the hydrothermal fractionation, you will get the hemicellulose and lignin and cellulose as well. So cellulose definitely it will convert into glucose, and you will get many kind of products out of it. If you go for the hemicellulose section, and lignin extraction is there, so lignin for the after pyrolysis is converted into bio oil and carbon microsphere. And at the same time you can use this thing as a ionic liquid plus hemicellulose, which will be go for the anti-solvent extraction. Anti-solvent extraction is means whatever the solvents are, if you process it, if you it already has solvent inside it, so we have to remove the solvents. You will get the precipitate hemicellulose and ionic liquid separate. So for that some specific kind of solid gas catalysts are using, which is known as SSCS, and here it is mentioned which are the catalysts, and then what are the characterization process is followed. So this content is little bit different from the professor's content, but this is first for your information. You have to follow most of the content which is described by the professor in order to get a good marks in the exam. So first generation ethanol, which is now the sugarcane is converted into juice, sugar and ethanol. Then in the every stage you will generate straw, bagasse, molasses and wine acids. All things will become into the sugarcane residue, and there are range of products from energy, saccharides, enzymes, organic acid, ethanol, lipids, food fuel proteins, and biopolymers are got produced from these sugarcane residues. Now integrated soybean sugarcane based refined biorefinery. So sugar and soybean are always comes together in the biorefining concept. Like here you can say sugar as well as soya meal, or both are there. And if you are using the processes, then you will get the product out like biodiesel, cellulose nanocrystal, cellulose nanofiber. These are the upcoming. These have the many applications in upcoming industries of electrochemistry, as well as semiconductor industry and many more. And the biogas, ethanol are the and electric energy, you can anytime you can generate electric energy and increase out of it. And this is how this integrated soybean sugarcane based biorefineries work. Sugarcane, okay, and soybean. If you go to agriculture stage, sugarcane will go for the juice extraction process, and at the end after juice you'll get the sugar out of it. We'll quickly go through it. And if you this juice you convert into fermentation filtration, you will get the ethanol, and ethanol purification, and you will get the ethanol out of ethanol. If you go for the transesterification phase, at the end you will get the biodiesel and glycerol, and you can use the ethanol also as a product. And if you go to vinyls the stage and anaerobic digestion, then you can generate a biogas out of it. And this is all about the 1G ethanol. This is a 1G ethanol process. Now the same, if you again the juice, whatever the sugar juice you are mixing with it, and you can use into the another process of ethanol production, where you again use this sugarcane pretreatment, hydrolysis, separation, and at the end you will get the out of fermentation you will get the wine and HEM biogas, which is nothing but the uh, product after the ethanol you will get. And at the end you will go for the cellulose nanomaterial stage, where your unhydrated hydrolyzed biomass is converted by the lignification and hydrolysis purification process into CNC and CNF, which we have seen. So this is major kind of products, and these are the stages of the these two of the raw material can be integrated together to form various products out of it. If you go for the integrated alga and lignocellulosic biorefinery, then it is mentioned over here that microalgae strain has many kind of functional food ingredients like vitamins, lipids, proteins, and pigments. Lipids are basically fat which they have. So vitamins and minerals will be going separation and downstream process. You will get ascorbic acids, potassiums, and different kind of vitamins as well as some kind of nutrients out of it. If you go for the lipids, then solvent based extraction and saponification process, you'll get nutraceuticals or health promoting substances out of it. Go the protein, and then you go this bunch of the processes out of. After that separation, extraction, DSP, you'll get a product like amino acid and lecithins and like this by video products. And lecithin is also one of the product which is a amino acids out of it. Pigments, then because microalgae has color, then what different kind of products out of it. And then algae has different kind of products which is mentioned over here also. And at the same time which is mentioned here, we went too much detail in the last lecture for all of this topic individually, so that's we can skip now. So algal biorefinery is basically any kind of wastewater you have, either industrial, domestic and commercial, all have nitrogen, phosphorus and uh, potassium in the as a nutritions in it. So it will go for the microalgae cultivation, and we can cultivate microalgae there. It requires this wastewater and solar irradiation, and it will be eventually converted into the harvested biomass, which is harvested out of this microalgae. This biomass will be go for the biochemical conversion. In the fermentation, you will get the bioplastic. East fermentation will get bioethanol. The dark fermentation will get biohydrogen, and anaerobic digestion will get biomethane. This is how this whole process is taken place. Will not go into the much more detail. Microalgae cultivation, you will get the animal feed as a product. You can use it. You will extract a repair and develop treatment and all. You will get the uh, organic waste biomass, biomethane, and the digested out of it. You will get the bioethanol, bioplastic, hydrogen, as well as biomethane out of it, which can be used for the source for heat and power generation at that. Now the question asked is, food waste is one of the most commonly generated bio waste in developed countries. Now question asked on food waste is the major drawbacks of traditional treatment technology employed in the valorization of food waste. And now the valorization is the treatment of the food waste. So what are the disadvantages? The disposal of food waste is the results in loss of valuable nutrients. So food waste biomass has been mostly used for the production of biofuels with the aim of partially completely replacing highly polluting fossil-oriented fuels. But what are the disadvantages? Disadvantages are the excessive time-taking process, poor feasibility, high cost, and the emission of greenhouse gases and sludge production. So it is mentioned as sludge production, the emission of greenhouse gases. So what is the major drawbacks? So answer is both A and B, and that this is mentioned in the same slide. Now waste biorefinery, as we mentioned, so which mainly consists, as which started this kind of food waste, which is consists of food waste as well as different kind of waste, agricultural waste, industrial waste, commercial waste. So if you talk about the petroleum based linear economy and bio-based linear economy, so here it is how much waste is generated and how can we integrate together this whole waste biorefinery to get reduction in the CO2 emissions, and to get uh, uh, whatever the sewage water and wastewater is there, to reduction in all this process. You'll get the biofuels, treated water, bio-waste products and bioenergy out of it at the end. So it is self-explanatory. Now the question asked is the blend of hydrogen and methane gas of which we consider is, here it is producing hydrogen as well as methane, both of it, but mostly it is producing hydrogen and methane together, which consists 10 to 15% hydrogen, 50 to 55% methane, as well as 30 to 40% carbon dioxide together. Altogether are known as a biohydrogen. Hydrogen comes in the hydrogen and methane, and it is a bio means it has CO2 percentage also. Otherwise, or if you talk about only hydrogen, then it contains a hydrogen and methane mixture. Now the question is, what is the typical composition of the biohydrogen? Then the answer is 10 to 15% hydrogen, 50 to 55% methane, and 30 to 40% CO2. Now it's considered as an energy carrier because it has obviously hydrogen and methane in it, and it can be able to replace the fossil fuels in the biological processes because it is generated after the biological process. The burning speed of hydrogen is about 7-fold higher than methane, Then if you are combined together, then reducing the burning time of engine, but you can have to remove CO2 out of it first thing, and then it eventually remove the emission of greenhouse gases and CO2 gas. Now the another question asked is the same food waste is the main component responsible for the production of hydrogen from food waste are what? So when we talk about the hydrogen production from the food waste, that mainly come from the starch and cellulose part. It is mentioned over here. Hydrogen is produced from the food waste rich in starch and cellulose, and the dark fermentation process is always taken place when you want to produce the hydrogen. In dark fermentation, we discuss in detail in the previous chapters. In that, during acidogenic stage of AD of organic matter, which is considered to be promising technique, where you will get the hydrogen from this biomass. Energy recovery, if you talk about 7 to 9 times greater by the combined production of hydrogen and methane than conventional hydrogen production or not. That's why if you go for the hydrogen methane combined production, which is known as a biomethane, which we see, then the output of energy is much more higher, and um, it will be two-stage fermentation, and you will get a maximum recovery out of the food waste. So here the hydrogen is from cellulose and starch, which is mentioned over here. Now, if we go for some financial or techno-economical aspects of this biorefinery or integrated biorefinery, then there are many aspects that was mentioned. There is net present value and internal rate of return. We'll just go through these two because there was question asked out of it. The NPV is the net present value, and it's determined by the calculating the cost, negative cash flows and benefits. So what are benefits? It's what are costs you are getting, or whatever the cash flow which you are getting after the selling your product or selling your technology. So that is a benefits. It is a inflow cash, and this is a which is a cost which you are spending, which is a negative cash flow for each period of investment, and by discounted the value over a periodic rate of return. So net present value is how much net revenue you have after the every year, and you will go to discount what is the value rate of return is there. You have to go take and get to discount of that also. Now the internal rate of return is defined as the discount rate at which the NPV equals zero. So net present value is zero. That means if you earn 100 rupees, then you invested 100 rupees. That there will be no profit, no uh, no profit, no loss. So that's why internal rate of return that means that the present value of the positive cash flow for the project would equal to present value of its costs. So that's why if your internal rate of return is zero, then if that's why it is exceeds the cost of capital, then only it is worthwhile. Otherwise it needs to be checked that NPV should be greater than zero and internal rate of return will be high, and it needs to be exceeds cost of capital. So the question asked is the internal rate of return is defined as, so here it is clearly mentioned the discount rate at which the NPV equals zero. So this is no profit no loss kind of situation. Now in the techno-economic analysis assessment we have went through last time, there will be you can conduct this thing which is connected into the upstream supply side, midstream refinery or downstream what is the product and demand side. So what are the feedstock you are getting it, and you have to go for the market study, technological assessment, economic assessment and sensitivity analysis. These are the four important aspects, and information will be go through each and every stage. And from information for getting all this doing all this study, you will get the information from the product side or downstream demand side and upstream supply side. Similarly, there was a question asked here, what is the first step in performing the financial economic cost analysis benefit? So before performing financial economic cost analysis, the investment must be contextualized into economic, institutional, social and technical framework to identify relative barriers. But the first step is to identification and description of both the benchmark scenarios and the investment scenario. So the second step is identification of investment outcomes. So first step is you have to identify this in this script. You have to understand what is a benchmark scenario, what is the ideal scenario of your processes, and what is the investment scenario. So answer is this one. This is mentioned here in the first step. It is. This is your answer. Now there was one question on the life cycle inventory, which is what is the amount of pectin, hexogens, and pectosans are produced in the citrus waste generated after the extraction of juice. So, so there is a life cycle assessment in that. There was a question. There was a uh, one kind of example is taken place. In that example, if we talk about the citrus waste, there was a juice based whole what you can say for an example, they go for the life cycle assessment of whole juice biomass treatment and production product conversion into bioproducts. So it is mentioned there. So 20% dry matter consists juice consists, and which has amount of 25% pectin, 26% hexogens, and pectosans at 7%. So this is the answer of this 25, 96, and 7. Now the techno-economic analysis and assessment, as we see, study technological assessment, economic and sensitivity analysis, and we go through one small example integrated with this schematic diagram, and we have already gone through last time. So for first in the technological assessment, you have to find the variable input variable, and that will be go for the process flow diagram and mass, and by using mass and energy balance. There you will then at the end whatever the result you will get, it will give to the economical assessment team, or you perform the economic assessment where you will go for the capital expenditure, operating expenditure, revenues, and this you can see some intermediate variable, and then you will come for the NPV and IRR, and then you will see that how is the techno-economic analysis going on, and that the life cycle assessment. uh, this is the, I think, last slides of today's discussion. Then we go for the all weeks content again. So in the life cycle assessment, specify how to first specify the decision variables we have seen last time. So just going for the decision variables the first, which is unit of operation, operating pressure and temperature kind of thing. Then define technological parameters, that what you are aiming for, highest amount of yield, maximum production, what is the efficiency of unit of operation. Define contextual parameter, which are the location and incentives. We are going for the operational things, and feedstock composition systems. Establish design in algorithm. So all this design you have go for the automated design, which in the algorithm point of view, like process flow diagram and all, you go the equipment requirement, construction, end of life phase emissions, generate agile inventory data in that automated simulation, and characterize the cycle sustainability. Then you will go for the what is the impact and cost analysis of all this process step which you have taken care of, and lifecycle assessment. After that, you will go for the product actual design of this refinery concept. So this is how process engineering software, lifecycle thinking software, multi-objective optimization, design thinking, everything will be come together, integrated with each other, and then you will get for input some, you'll for some of your input you will get some output, and you will get to know that, oh, your project is how much is worthwhile to take on up. With this, I want to quote Carl Sagan, which as like every end of the presentation, but this is not end today. So he mentioned it pays to keep an open mind. Uh, for if you want to keep open mind, then it requires some amount of thinking out of it, but not so open your brains fall out. So if you, it is not you have to think that much that your brain will fall out. So you can be open mind, and you it will be helpful for you. So with this, I guess we'll switch to the content. Wait a minute. Yeah. So here we start with the first chapter which I took. So biomass conversion and biorefinery. In the first lecture, we mostly went through the introduction point of view, which will be not much important. Course certification, 25% is assignment, 75% is the exam. So you have to be focused in your exam. This is outline of course, books, introduction. In that, We can see International Energy Agency, US Energy Information Administration, and Europe Environmental Agency. These three producing some data every year. That will be helpful. And then we went to the Paris Climate Agreement, which is we have to limit the carbon dioxide emissions and the temperature of global temperature, which is more less than 1.5. Go for the classification of energy. Primary energy, which we are getting currently mainly from the conventional sources, waste, as well as some renewable sources. Then transformation to consumption, so obviously it's fine. Classification in which other different sectors, how conventional and non-conventional is distributed among themselves. Classification of energy and the in context of India. So in the first lecture, we don't have to see much thing. Climate change, past and forecast, world energy scenario, what is different kind of uh, different possible features out of it. Stated policy scenario, new policies, and you have to you have to go through these concepts like what is a stated policy scenario, so which is already we are using other new policy scenarios, or go to sustainable development scenario, which we can use for the sustainable development. Now global energy demand will be plateau, that is an important factor after 2035, so we will see that there will be no much global energy requirement, will be means increasing year by year after that. Then which are the sectors like energy supplies, in which are the proper country wise, how it is, which kind of energy source they are using. Primary energy, again that too depends on the global energy and global primary energy, the forms of the stated policies, sustainable development, and current policy. Current policies are like this: if you are using, we have so much emissions of CO2, we go with stated policy, which are ideal little bit in the current state. But if you go for the sustainable development, then the policies will be helpful for reduction into the emissions. Similarly, we have gone through some videos. Yeah, renewable future helps, right? If there are some data of it, CO2 emission forecast for net zero emissions. So we are just like this only, we are skimming on the first, maybe in the first lecture you will not find anything important, or you maybe not remember also, but yeah, it's fine. Environmental impacts of various sources of electricity generation, and the same need for biomass based industry, sources of biomass. So that is a lecture 2. We start for the biomass sources, then biomass sources mainly from the municipal waste, sewage, animal manure, forest residue, and agriculture crop residue. And then IRENA has some the key findings, which is the roadmap, renewable energy map 2030, where most of the worldwide renewable energy technologies will be useful. Okay, like this will be fine. So all the key findings are important on the point of view the assignment questions. Global biomass demands and supply, influential factors for biomass prices. So increase demand, increase production costs, which are the important factor. Decrease supply, low stocks, market dynamics. This will be helpful in for if you go for the biomass price. Then biomass to bioenergy routes. Obviously, this is the how this glucose is come. Then it will go for the this kind of different biomass. It has this glucose in it. Then it will go for the conversion processes like anaerobic fermentation, gasification, pyrolysis, hydrolysis, crushing. And you go for the biofuels and bioenergy out of it by using, if you go again, fermentation, process, esterification process, go for different kind of applications, and then of all these products. Charges related to biomass. Operational challenges are feedstock unavailability, regeneration, availability of biomass and storage problem, pressure on transport section, inefficiency of conversion facility, coal technology and equipment storage, economical challenge it is mentioned, or which are the economical challenge for this. Now the demand and supply of bioenergy networks and land demand, land use and energy productions. And after they using what is to the open remaining and land is there, so how can we use this for the primary bioenergy? This is all about the optimization of the land and suitable area for agriculture. How can we distribute among each and other thing? Now for the problems, it mentions the solutions also for the biomass conversion. residue. Uh, like if you talk about high quality biomass is considered limited expensive. Nuclear is microforestry industry residue. This kind of all problem solutions were mentioned by Professor. Biomass eventually go for the biorefinery, will go for the fuel solvents, bulk chemicals, plastic fibers, and chemical oils. These are some of the examples, which is again and again coming. So I don't want to go. Biorefinery just visited the biomass is conversion. Biorefinery will get tons out of product out of it. So these are some. So this is all about the first thing, first lecture which we see. Now we will go to the week 2 content. So I need to find it. You download it and keep save. Yeah. I will go for the week 2. Okay. So this is all about biomass availability. Started again a little bit same thing we discussed in the week 1. So every week the second half is discuss about the second week content. So this is the same thing. Now we start with the photosynthesis. Then you can see that photosynthesis process. This is the equation. There are some questions asked from this one. That this which is we mentioned direct reaction in photosynthesis, right reaction in photosynthesis. So to if you like reaction, the splitting of water molecule into hydrogen and oxygen is happening under the influence of the chlorophyll and sunlight. The direct reaction, hydrogen is transferred to carbon dioxide to form starch and sugar. So these are the two important things. Wait. Then biomass composition is there. So mainly it consists of cellulose 30 to 36%, hemicellulose. You can check the figures in the professor's slides, that will be much more important. But mainly it consists cellulose, hemicellulose, lignin, some of the extractive and S parts. Then we go for the cellulose, which is mainly glucose combined together in the polymer long chains, and it has only single monomer, which is a glucose. If you talk about hemicellulose, then it is various pentoses and hexoses together, which is like for an example xylose, arabinose. Hexose like mannose, galactose, and glucose. They are combined in random fashion. If you talk about lignin, then it is mainly the aromatic alcohol like coniferous alcohol, but it is a complex. There are comeral alcohol and synaptic alcohol. This biomass has the biomass cell and how it's, different part is come into the cell. Now the questions, some of the questions on the hemicellulose, and will not go through all the questions because it will be waste of time of you. This is the hydrolysis process of cellulose, how it will take place, and that is a pre-treatment which is required to separate this hemicellulose cellulose as well as lignin out of it. That's why first you can see cellulose lignin uh, will be incomplete hydrolysis are dead. It's like that if you go for the complete hydrolysis you will get the cellulose out cellulose differently, glucose differently, lignin and everything separately. Then there are some questions. Virgin biomass production and selection. Now, virgin biomass productions, in that there are steps. One is the insolation. Insolation, we have to understand that how much solar radiation is there. Precipitation. What is the precipitation of water? Rainwater is there. Temperature. What is the range of temperature we are working on? Which kind of bacteria we are using? Which will be sustained into a temperature or not? Then it comes to the municipal solid waste. Then this municipal solid waste has many kind of products like inorganic products, aggregate, fuel, a different kind of solid food, liquid food, and gaseous fluids out of it. And as energy resources, you are using biomass from various feedstocks from, and you will get the various kind of biomass classification feedstock. That's it. And depending on the classification of dedicated feedstocks which has, we are using some sugar crops, starch crops, and oil based crops. Some crops basically just for the biomass purposes, and some residues which can you also use for the biomass treatment purposes. And corn to bioethanol process, jet to power life cycle process, and how this corn will be, how can do what a process, which are the XID FTA. These are the analysis you will perform for your product quality check. and this jet of a life cycle is also mentioned. The moisture contain different biomass, which is important factor, and it will be uh, there for the deciding factor for your biomass production. The classification of biomass from generation. So first generation feed crop, food crops. If you go for second generation biomass, then lignocellulosic feedstocks. The third generation microalgae and genetically engineering microorganisms, which is the fourth generation. So this is how different kind of generations are there for in order to biomass production. Biomass properties of biofuel, if you want to see, then there are questions from physical properties to density, apparent density, porosity, bulk density, and biomass density. Other than the thermodynamic properties are the thermal conductivity, specific heat of different kind of energy, heat energy, and increase in temperature. Challenges, which is moisture content, density, complexity, diversity, and leak trends, which is a resistance control and dissolution difficulties. Then week 2 is biorefinery. It's all about the biorefinery, oil refinery versus biorefinery. Biorefinery concept we have gone through, which are the definition point, biorefinery, sustainable processing, biomass. These are the terms which needs to be present in the biorefinery. Types of biorefinery: conventional whole crop, green, tow platform, thermochemical, marine, forest based, depending on the feedstocks. The marine algal biorefinery due biorefinery classification approach, where it is based on platforms which are basically feedstocks or basically intermediate products or final products. Platform is the products, feedstock is different. Processes, which kind of processing you are using, and products. So these are actual platforms are intermediate products, but which is important products, and these are the final products. So if you have a feedstock in primary, secondary, tertiary, and depending on this kind of feedstocks, organic matter, it is explained what are the carbohydrates. These basic hydrocarbons are there, then lignin, cellulose, pectin, semicellulose are present in it. And how can you classify the biomass type? Classification biorefinery, economic calculation based on it, life cycle assessment, step 1 goal, what is your goal of final uh, process. Step 2 is inventory and data collection. Step 3 is impact assessment. Step 4 is research interpretation. Now this is the end of the second lecture. Go for week 3 content. I will go into a little bit fast, so maybe you will get your time to go through the topics, and because there is no sense of doing discussion again and again. So week 3 is all about again this biorefinery. We checked under the week 2 content already. There was question from the International Energy Agency Bioenergy Task 42. So this is the agency which they use, which define the biorefining process. Is a sustainable processing of biomass into a spectrum of marketable biomass-based products and bioenergy, and you will get this biorefinery thing again. Types of biorefinery, we have gone through it. Biorefinery processes. Now week 4 is biomass pretreatment. So which are some barriers in lignocellulose biomass conversion. So this is all about the pretreatment. This is the first step of biomass conversion. So which kind of pretreatment you can go? Chemical composition of the lignocellulose biomass. First you have to understand lignocellulose biomass is there. So what come out of cellulose? 35 to 55%, 25 to 30, 35% hemicellulose, 15 to 28% is lignin. The chemical composition which we have gone through before. This again the separately it is mentioned what is a cellulose, which is nothing but the D-glucose unit linked together by using beta 1 for glycosidic bonds. Then hemicellulose, what are the terms? It is how it is combined together, different kind of pentoses and hexoses. And lignin. So lignin is basically complex uh, aromatic alcohol. Then how it is some units are converted. Now there is a question, the main focus on recalcitrance. So it is defined as a natural resistance of plant cell walls for its biological conversion, mainly caused by the complexity and heterogeneity of biomass. So as we know that biomass has a plant cell, which comes from the plant, so it has a plant cell walls, and it is basically it has natural resistance into the processing of this plant cell walls, and this is all about the recalcitrance. And then if you want to understand more detail, then you have to go to what is the role of recalcitrance in different things: cellulose accessibility, cellulose crystallinity, lignin mono, lignol distribution, lignin molecular weight, lignin phenolic hydrox group, and in each and every part this recalcitrance has their role, and it will impact on each and every part. So now the main thing, pre-treatment. Now what are the useful for the pre-treatment? Removal of lignin, removal of hemicellulose crystalline, and reducing the crystallinity of cellulose and different things. So that's why pre-treatment is useful. Now if we talk about pre-treatment, then there are biological pre-treatment, chemical, physical, physiochemical, all kind of pre-treatments are there, and out of it you will get different cellulose, semicellulose and lignins separate. And if we talk about chemical, then acid, alkaline, weight, organic grain, and many more, physical, grinding, milling, microwave, ultrasound. So pre-treatment is basically you are going for the main process, and before that you are doing some treatment for your biomass feedstock. For the biological, then lignin degradation, cellulose degradation, physiochemical, steam explosion, supercritical, subcritical fluids, ammonium fiber explosion. Again, you can convert, you can classify physical, chemical, physiochemical, biological, and many more. And then if you talk about chemical treatment, then chemical treatment is also cellulose removal. Some treatment for cellulose removal, some lignin. Lignin has major process can be used for removal of lignin. Some are cellulose and some are for the semicellulose. And mechanical has thermal mill and different kind of milling operations. Acid pre-treatment is there where you are using the treatment by using the acids, concentrated dilute acid, organ solve method where you are using organic solvents, and pre-treatment using deep eutectic solvents. So you are using a deep eutectic solvents, which is a hydrogen bond acceptor and hydrogen bond donor. And then micro assisted DES pre-treatment, deep eutectic solvent. Then comparison of acid, alkaline, hydrate, acid, alkaline pre-treatment. These are comparison. There are questions asked for that one. This is all about the third week content. Now we'll move through the fourth week content. In the starting, the same thing of this week biomass treatment. So we can skip if it is something new. We can go through it. So there are questions asked, and for that it is okay. So now week 5, physical and thermal conversion processes. So after the pre-treatment, we'll go for the physical and thermal conversion processes. And physical means we are going for the physical conversion, like you are going for the drying operation, dewatering operation, you are going for the mixing, crushing kind of operation. Thermal conversion, you are going for the heat treatment. So starting with the dewatering and drying. So it's dewatering, it's remove all part of content moisture. Drying is small part of moisture will be removing. These are the dryers which can use rotary drum flares, fluid raspberry ring spray for the biomass treatment. Then the information about drying, and there maybe there is some videos I have seen, I have shown to you. Then another is the size reaction process. In size reaction, you're using the shredders, which is basically hammer mills, dry shredders. And then you go for the densification process where you apply the force, and your biomass, whatever the porosity is there, which will be reduced, and particles got interlock, and you will densify or increase the density of your biomass. Now separation process, where you can go for the municipal waste kind of process, which you can separate into the different kind of processes, and depending on the application you will use the biomass processes. So municipal solid waste, thermal conversion, recurrent line filling. So thermal incineration, pyrolysis, gasification, refuse data, fuel RDF, biological and anaerobic digestion, composting. And same is the landfill. Now in the thermal conversion process, uh, you can go for the food. Okay, so there was a food. If you talk about the food products, then food preparation requires some water addition, water remover, and so that will increase some give you some kind of waste which is known as a pre-consumer waste. If you prepare the food, you go for the service, you will get the food, consume the food, and then you will again generate some waste which is a post-consumer waste. Then food waste is all about. Then the gasification is starting of the gasification, where you are going with the all kind of feedstock. You go for the gasifier. Gasifier will have different sections like pyrolysis and different kind of section in it, depending on different temperature. And then you will go for the after some processes for getting your final fuel, chemicals, power, electric power, and different thing out of it. Now gasification reaction, there are many reaction uh, which has been done in the gasifier. But basically, if you go into the detail, then drying is there, pyrolysis is there, combustion process is there, cracking process is there, reaction is there, and this producer gas and char gas is the final product out of it. Then gasification is partial, with partial oxidation we go through with different kind of gasifiers we have seen, updraft, downdraft, entrant flow gasifier, and circulating fluid bed gasifier. Then go to bubbling fluid bed and circulating fluid bed types. Then there comes the supercritical water gasification, where we use the water as a supercritical as a solvent in the supercritical state, and that was sludge and all. We get the byproducts out of it. Use the sludge as your feed. Then pyrolysis comes into picture. Pyrolysis is the direct thermal conversion of the organic compound and the absence of oxygen. That is all about pyrolysis. You will get biochar and gas. You will use the biomass of lignocellulose, and you will get the some using technology you will get for some different kind of applications out of it. The pyrolysis types and reactor: fluid bed reactor, circulating fluid bed reactor, ablative plate reactor, auger screw reactor, rotating contact, and cyclone vortex reactor. And then explanation of and some advantages, disadvantages. In India developed DBT ICT 2G ethanol technology by from in the Institute of Chemical Technology and India Glycos Limited. This is all about the technology. BTG process is developed by the University of Twente in Netherlands. This is a fast pyrolysis process, and you will get the bio oil out of it is the main product. If you go with the fast pyrolysis, you will get the bio oil. The slow pyrolysis, you will get the biochar. And this is all about the week 4. Now we'll move to the week 5. Again in the first the same content of the okay. Now week 6, it's a microbial conversion processes. So basically we are using the microbes, which is microorganisms, which are not only bacteria, but we are using fungi like yeast and all many things for the production of processes for the production of bioproducts by using these processes, which are known as a microbial conversion process, mainly anaerobic digestion, fermentation, microwave fuel cell, and composting are the example. So what is anaerobic digestion? Without the presence of iron, we are going for the fermentation process or digestion process. 4 basic steps: hydrolysis, acetogenesis, and methanogenesis, by using the various kind of bacteria and various kind of enzymes out when in every step. In anaerobic digestions, we are using many kind of biomass. We go anaerobic digester, we are getting the fuel and gas, and that will be converted to heat and electricity eventually. So this is about the anaerobic digestion, these factors, and this in the phase 1 we will go for hydrolysis, and second say acidogenesis, third is acetogenesis and ketogenesis. Now explanation of all the steps of acetogenesis, we'll go for the some video on it. And then fermentation process, it's a enzyme catalyzed process where we are using the enzyme, and it's a metabolic process where organism converts starch or sugar into alcohol or acid or hydrogen, or depending on the feedstock. So in that first is the acid fermentation, which is lactic acid fermentation. You will get a lactic acid, and there is a acetic acid fermentation and the 1-butyric acid fermentation. Then if you talk about alcoholic fermentation, then you will get ethanol out of it. Hydrogen fermentation, which is direct fermentation, and other photo fermentation are the processes which we go through the much detail in the upcoming lectures in the after maybe in the hydrogen chapter and all. We have go through these processes in much more detail. Then the fermentation, which kind of fermenter we have to use: liquid fermentation and solid fermentation, like liquid substrate fermentation and solid substrate fermentation, where we are using the liquid and solid products separately for fermentation process. And then we go for the microbial electrochemical processes, So by using the microbead, which kind of electrochemical processes which take place when not, and there are in the using the this electron transfer for producing the products and for getting energy out of it. So it is our microbial and electrochemical chemistry together. Then it is a composting, which when we organic waste is go putting into the compost and we'll get the fertilizer out there. Then equipments are there. Bioreactor, now the bioreactors, which are the parts of bioreactors: sealing, baffles, impellers, sparger, feed ports, foam control valves, and types of fermenters. If you are going to pack bed, store tank, fluidized bed, airlift, tower fermenters. Now, what is the difference between bioreactor versus fermenters? So these are the fermenter mainly used for the fermentation. Bioreactor can be used for any kind of biochemical process. This is a major difference. Then you go with the other difference in it. This is all about the week 5 content. Now we'll go to the week 6. Now initially the microbial conversion process is same content for solving the same questions. And then we eventually go to the biodiesel, which is a week 7 content. So biodiesel is some oil crops which we extract oil out of it. We are refining the crude oil, and then it will convert it into the alcohol. That is a one step. If you go for the transesterification process, so alcohol will be converted by using this transesterification process. We'll get the biodiesel out of it. Now we'll go through the in detail what is the reaction and all. So mainly which kind of oil products, vegetable oils which we are using in biodiesels. But if you talk about the in India, we are not using the oils crops which are going for the food intake. So that's why we can rely on the products which are non-edibles like mahua, karanja, polanga, neem, rubber, jatropha. These are the seeds, and from this you will get the biodiesel. So this is the actual so in this, so water vegetable oil has a triacylglycerol or triglyceride, which is a triglyceride, which is a TAG, and which contains the fatty acids. Okay, so these kind of fatty acids are there, but it all are attached with the glycerol backbone. So means it's 3 carbon alcohol products. So this is a, if you can see, monoglyceride. So this is a glycerol. If you can CH2OH, CHOH, CH2OH, this is a glycerol, which is all glycerine, you can say. If you remove one of the OH and you put the one fatty acid, then this is a monoglyceride. If you put two and then diglyceride and to put three, then this is a triglyceride. And then also saturated fatty acid, there is no double bonds, that is known as a saturated fatty acid. If there is in between similar kind of stuck double bond is there, and the opposite similar kind of elements are there, then the unsaturated trans, and this opposite are in the similar side, then it's unsaturated Cs. Now for these for these fatty acids and all saturation, we have to find how much degree of saturation or unsaturation the molecule weights are there. So for that we can go for the iodine value and saponification value. So these are the equations we can use for that one. Now basically composition of all these different kind of oil products are there. They consist mainly saturated fatty acids like palmitic acid and stearic acid. They have unsaturated fatty acids like oleic, linoleic, and linolenic. This triglyceride will react with the methanol. All this glycerol or glycerin will be separated, and you will get the glycerin or glycerol out of it. And whatever the acid fatty acids are there, they can be converted to fatty acid methyl esters, which is biodiesel basically. CH3O is remove this all thing, and this from here, it's combined together, and this O hydrogen it is getting from this one, methanol from hydrogen from methanol, OH minus from you will get OH, and then you convert to the glycerol. Now this you can see vegetable oil, everything is a transesterification. You will get the methanol. You will use the methanol, and whatever unused methanol you will recover and again put it again back. You gas the glycerin and you will get the biodiesel out of it. Then you can use the soybean oil. The question asked on the specific kind of oils and main properties. Then there is another is a rapeseed mustard oil and canola oil. These all things are the same, from the same family, and there are different kind of oil production is also mentioned in the professor's uh, lecture notes, but I just focus on more majorly which are there in the assignment question. Now these are the processes of the biodiesel production, which you already seen. This is a video on it. Biosynthesis of algae by transesterification processes. If you use the transesterification, then you can use the algae also. This algae will become, if you extract the oil out of it, then you can again do the same transesterification. You will get a biodiesel and glycerin out of it. Biophotosynthesis from algae by transesterification process, algae cultivation, harvesting, biomass processing, oil extraction, and biodiesel production. Then syngas biorefinery, biomass can also produce syngas, which is nothing but synthetic gas, which is a mixture of carbon dioxide and hydrogen. You go for the refining, you will get the different kind of processes. You go for the methanol synthesis. After methanol, you will go for the dimethyl ether, and then a different kind of process out of it. And you can, from syngas, you can convert it into the hydrogen and methane also. Then this is a transesterification reaction. This will be converted into glycerin. Another will be converted into a mixture of fatty acids, which is eventually converted into biodiesel. This is a step-by-step reaction. Then there is an important parameter and very complex thing, which is a tuning. How you can tune your reactions in order to give the electron donation or electron withdrawal, and then variance will be there. You will get your desired product out of it. Then there are two basically route which was mentioned: weak back donation, semi-strong back donation. Now after that, you use for some processes like it's for the separation of it. First is adsorption processes, and advantage and disadvantage of refining technology or refining or separation technology. Then there is an important thing for the biodiesel is a CTN number, which is a mix which you want to which is a mixture of two chemical heptamethyl nonane and normal cetane. So cetane, you have to think of this octane is just for the comparison purpose. Whatever the biofuel you have, they will go for this mixture, and you'll see how much your characteristic is similar to the what is the fraction of mixture of these two different chemicals. Depending in it will your fast, more cetane number is go for fast ignition. This is also not good, and low cetane number is also not good. So you have to optimize your cetane number depending your convenience. This is all about week 6. More 5 lectures to go. Week 7, 8, 9, 10, 11. So it's 10 okay, we have time. So biodiesel, we already gone through it. Now it's all about the week 8, which is bio oil and biochar. So here you can see that how this bio oil production is taking place. Bio oil is definitely you will go for the pyrolysis process. Biochar, if you go to fast pyrolysis, you will get biochar, bio oil, and syngas. Slow pyrolysis, you will get biochar, syngas. So bio oil, if you want, then you go for the fast pyrolysis. Otherwise, you will not get bio oil. Biochar you will get anywhere. Slow pyrolysis, again biochar activated. Biochar and syngas gasification process, you will go biochar, combustible ethane and methane. If you go for the carbonization, you will only get biochar. Now this is a processing like drying, conditioning, torrefaction process, exothermic pyrolysis and endothermic pyrolysis. These are the steps. After that, you will get your final product out of it. Then what is the market of biochar, which is increasing day by day, and what are the application of biochar? Products and applications. The fact happening biochar chemical properties. One is atomic ratios, so how much carbon, hydrogen, oxygen which is present in there. Elemental composition is also taken place. Energy content is there. Fixed carbon and volatile metal. What is the functionality of a biomass as content and composition? Then physical properties like density, porosity, and surface area. And then reactor for biochar production. So reactors are basically pyrolysis reactors, and these are the gasification or gasifiers, you can say. So gasification process, you are drying, pyrolysis, combustion, production. which have gone through before that also. So pyrolytic gasification is the overall process. These are the important reactions, some of the important reactions. There are many reactions taken place in this process, and then there are some kind of reactors which are taken place rather than this gasifier. One is egg auger reactor, the same process going on, but it has main different thing is it has screw which is going to moving to the direction, one of the direction. If you talk about bio oil, then bio oil production by the fast pyrolysis, then bio production by the fluid. So what is the kind of reactor? Fluidized bed reactor. So here fluidization going for cyclone separator, you will get separation out of it and you will get bio oil. Another is a rotating cone reactor. This reactor is a cone kind of reactor. It is rotated with high speed and you will get the bio oil out of it. Then fuel characterization technology, we use the different kind of characterization technology like acid value, hydratic value, density, kinematic viscosity, the moisture content, methyl ester conversion, phase number, cetane number in order to characterize your fuel. And one is the water content determination, which is important characteristics. And bio oil upgradation technology, which it is need to upgrade bio oil in order to convert into the other products. First one is most important, of course, the improvement of bio quality. Another is you can go for the overcome the fuel quality deficiencies. For upgradation, you will go for a zero right cracking. There are different routes are there. Fast pyrolysis upgradation, you can see. And bio upgradation, you will go for the this kind of pyrolysis and combustion kind of setups. Now there's biochar, the biochar characterization, chemical characterization, physical characterization, pH, BT, FTI, CEC, and NMR. For physical, then SEMTM, ice content, pore volume, X near edge structure, moisture content. You can see physicochemical, surface chemics. See, you need to understand these are all the analysis characterization technologies for understanding the quality of your final products. Now this is a process flow, and this is all about the week 7 content. Go for the week 8. So biochar, bio oil, we will go through it. So bioproduction with ablative reactor was there, which is a not cover. Biochar benefits are there. Supercritical foods are also used for the pyrolysis process. Now week 9 is the bioethanol and biobutanol. So mainly corn will be useful for conducting the bioethanol processes. Pre-treatment of biomass in the bioethanol process, milling, cooking, liquefaction. Dry milling process and wet milling process differences and what is the important thing you have to take care of it. Mainly dry milling doesn't consist, you remove the slurry and liquid out of it. Wet milling consists some water into it. Then cold starch hydrolysis process is also there, cold starch. Pre-treatment of biomass, which we have gone through it. The pre-treatment is a chemical, physical, physiochemical, biological. Ignosolus biomass processing, and then there are four different kind of process: separation, fermentation process, simultaneous separation, fermentation, simultaneous separation, carbonization, fermentation. So these are the different kind of process approach you can take place. Then which are the enzymes involved, that is also discussed. Corn-based ethanol production was there. So what is the process and what are the enzymes involved in that? So cellulose structure, if you talk about cellulose, then there in 1838 French scientist Anselm Pine, which is the first one who is the discover the cellulose in 1830, and in 1833 he discussed the enzyme which is a diastase, which is starch converting into the cellulose. And cellulose bioconversion, the three enzymes which will be using, these three are the names are given. And then there is endogluconesis and exogluconesis processes are there, and beta gluconase depending on which kind of enzymes you are using. And simultaneous saccharification and fermentation process, SSF and SHF. Simultaneous saccharification fermentation advantages and process in explanation. Acetone ethanol butanol fermentation, then it is known as AB fermentation, where you use the signocellulosic biomass pretreatment detoxification fermentation. At the end you will get the mixture of acetone, butanol and ethanol. and these are the process, and this is all about the week 7, so week 8, sorry. So I just want to complete as soon as possible, so you, for everything you already have. Okay, so first is biomass, bioethanol. Then week 10 is hydrogen, methane, and methanol. So can go for the biomass converted to hydrogen, which is basically synthetic gas formation is take place, and synthesis formation if you go for the water gas shift reaction. So then eventually we'll get CO plus H2O gives CO2 plus H2, which is hydrogen out of it. So first is the biophotolysis of water by microalgae. So biophotolysis, there are indirect biophotolysis and direct biophotolysis. Direct biophotolysis, you will use the sunlight, and in direct biophotolysis, you will directly not use sunlight. But in the stage 2, you will use the sunlight. So indirect and direct is the fermentation. In the fermentation step, you can use the sunlight. Anyway, it is discussed before. Then there is a photofermentation. You will use the light and biomass, which is eventually go for the photofermentation process, and you will get hydrogen out of it. This is a different kind of bacteria. It is known as purple bacteria, which is used in this processes. Depending on the microalgae and the color of the bacteria is quite simple. When it is be in the process, it you will get the different color. That's why. Direct fermentation process, we are not using the sunlight over there. Pre-treatment direct fermentation, you will get hydrogen organic solids. How it is taken place. Direct fermentation by different two kind of anaerobies, strict anaerobies, facultative anaerobies. So strict anaerobies are basically Clostridium sp and facultative you Enterobacter sp. So the strict is minimizing the contact with exterior oxygen. You don't have to use oxygen, or it does not have to be contact in the, you just get the contact of oxygen. But here they are less oxygen sensitive. They little bit contact is there is fine, but you will get the more production in the strict anaerobies. But it depends on the process and process. Then biogas production. So go for the bio in the biogas production, like methane CO2 biogas production, you go for the biofiltration. So what are the hydrosulfide which is there, which will convert into a element of sulfur sulfate, because it will be detrimental. Then biogas production is by using the anaerobic digestion, and these are the parameters, design parameters you have to keep in mind. Then fixed dome digester and floating dome digester, which will be developed by the Jasubhai J. Patel in 1956. The methanol from natural gases. So this is a conventional route of producing the methanol. Then the green methanol production is the different processes is there. Now what are the uses of methanol? And this is all about week 9 content. Now we'll go to the week 10. This is same lecture as well as organic commodity chemicals from biomass. So similar kind of thing. Now organic commodity chemicals which are commercially used for the as an intermediate to producing different chemicals, or which are basically used as a direct product out of it. Then chemicals from biomass. So which are there are many kind of information is there in this chapter. So we'll go through the just biomass is synthetic gas, and you will get a different range of chemicals out of it. So it's derived from the pentose derived commodity chemicals. So what is pentoses are there in the biomass? They can also convert into one kind of chemicals. Hexose derived commodity chemicals are there. Lignin derived commodity chemicals are there. Lipid derived commodity chemicals are there. Pentane protein derived commodity chemicals are there. Depending on any of your product which is present in your biomass, it eventually convert into some kind of chemical at the end, because it is also one kind of chemical. So if you can extract it to some kind of important chemical out of it by using reaction and yeast enzyme and all, it will be helpful. Succinic acid production processes. Now some of the production processes we have gone through in much detail because there are important chemicals. Then propionic acid production processes. Then polylactic acid or PLA, which is basically used in the packaging materials. It is a biodegradable. 1,3-propane dye production processes, 2,3-butane dye production processes, PHA production processes for ethyl hydroxyalconate, and this is all about week 10 content. Now only last week is remaining, which is mainly integrated biorefinery we have discussed. So this is all about the organic chemicals production. So integrated biorefinery, which we today also we discuss, which is basically the replica of the crude oil biorefinery, and how it is integrated together. There are some definitions of integrated biorefinery. It is classified into the different phases like phase 1, phase 2, phase 3. Phase 1 and 1 feedstock, phase 2 also 1, multiple processes, multiple products. Phase 2, multiple feedstock, multiple products. Based on the technologies, there are 5 different technologies. Now we'll go for the production and integration. We have today only discuss corn based biorefinery with import of corn, and this process is soybean based biorefinery. So in this we don't need to go again. This is today only we discuss in integrated sugar cane based biorefinery and algal cellulosic biorefinery, algal biorefinery, waste biorefinery, techno-economic analysis and life cycle assessment, which is two important thing. Here you have to go for the four major step, which is market study, technological assessment, economic assessment, and sensitivity analysis. You have to go for the information which is come from the product side or the supply side, and is how it is taking place. Today only we discuss life cycle assessment, 6 different approach. There are many more different things depending on your goal and depending which process you are following, and but this is majorly these steps. Life cycle assessment, this is all about week 11 content. So with this I want to stop now. I don't want to take your more time. So if you have any question you can ask, or you can leave if you want. This is all about the last lecture discussion on biomass conversion biorefinery. Sorry I took everything in very rapid speed, but that is the only option, otherwise we can't cover. We can glance to all the topics. So I also got revised something, and maybe that will be helpful for you as you are going to sit an exam. If you are, other than, it's good for the learning. And with this I can say all the very best for the all the students for the exam. Whosoever join my meeting, whosoever watch my videos on the YouTube, and I will appreciate your efforts to taking this course and taking the understanding my content, and um, whatever the discussion which was taken place. With this, I am Bhavik from IIT Madras. You can, maybe you have my number. If you want to ask anything before exam or till exam, you can ping me on the WhatsApp. My WhatsApp number is only running. I'm in the Australia. Sorry, I'm in the Australia, so you can see me. You can talk with me on normal call. You can drop an email anytime. So with this, happy to interact with you all. Have a great future ahead. Happy learning. Be be positive. Take care of yourself. And if you are going to sit in exam, all the very 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 best to all of you. And that's it from my side. Uh, all the very best again. And I'm stopping this meeting.